All right, so today we're going to be talking about GraphQL vulnerabilities, so let's just jump into it here. GraphQL is a query language that's meant to provide efficient communication between clients and servers, and this is because the client specifies almost exactly what data they want in the response, which in turn, shortens how long the responses are because your queries are being more specific. More importantly, though, the client doesn't need to know where the data resides on the back end. GraphQL does all that heavy lifting. And then it's also useful because GraphQL is integrated with a lot of different programming languages. So it's pretty easy to set up and use for a lot of different, legacy applications or REST APIs or things like that. So that's why it's popular. And that's why there's, a need to understand stuff about this because it's not just some obscure technology, right? But let's talk a little bit more about how it works. I linked a great resource here. I'd recommend reading through it, but also the official docs on, like the Apollo docs for GraphQL are also really useful. And like any, query language type thing, you're going to be interacting with schemas, you're going to be sending queries, and then mutations are how you actually change data that's being stored, right? So the schema holds different things. The schema holds objects more specifically, which they call types. And those are implemented by a service. So like in this case, right, we have the subscribers object that stores the name and email fields. So when you send a query to this in the schema, it will pull the values of those fields based on, your query. So this is what the query response might look like. If you query subscribers, it might reply with the name and email values for each, for each developer that meets the requirements, whatever it might be. That's really the gist of it. Mutations we'll talk about when we do our lab here in a minute. And those are just, ways you could change the data. So if you wanted to add a user, there might be in the schema a mutation that lets you add a subscriber in this case. One important thing, though, is the introspection query. And this is kind of our bread and butter because by itself, this is like either an informational low or medium, severity finding, depending on how much GraphQL is implemented in this API. But it's also just kind of a low-hanging fruit. So if you query the schema variable by default, you can get basically a copy of the whole schema, all of the, and this is a short version of the introspection query. There's a much longer one that will give you all the data you see here. This is a screenshot from GraphQL Voyager, which we will use in the lab also to kind of visualize, and it can even help you make queries, which is really handy. So, but the whole point of the introspection query is that it can disclose a lot of information to attackers. And if you can already run a regular query, odds are you can do an introspection query. But, as you get into exploitation, the first step obviously is going to be finding an endpoint. So let's say, you're looking at an application that's a store and you notice it uses a GraphQL query to pull the product line, right, by like their product ID or something. So that would be a good example of finding it. If you don't see the endpoint there, then you might want to just pull up FUF or GoBuster or something like that and start doing directory enumeration with some special word lists. And odds are you'll find a GraphQL endpoint of some kind if it's there. The Burp Suite scanner is also pretty good at finding those if you miss them, or if you just don't realize because it sometimes is formatted and is pretty similar. It's always JSON data, so knowing it's a GraphQL endpoint kind of depends on how it's used. But when we talk about unsanitized arguments, that's just referring to, like in the example I just described, let's say that website only gives you in the response like product ID 1, 2, 4, and 5. So you know that, ID product 3 is probably obscured from our vision. If you can query that directly, that would be an example. If you can query ID product 3 directly and get a response back that's accurate, that would be an example of like an unsanitized argument, right? Because they're hiding it, but not really, if that makes sense. Or moreover, just allowing you to query anything and get a good response back would be an example of an unsanitized argument. Now, obviously, introspection makes all of our lives way easier as attackers because we can then see like kind of a map of the schema and, we can figure out how to make certain queries. We might figure out where sensitive information is. And so introspection is really valuable. One of the first defenses you'll see is developers trying to stop us from accessing a schema. And I mean, it makes sense, right? If we can get so much information off of it, they would want to blacklist it or, not let us use it. So, for example, if they are blacklisting like the double underscore schema as the query type, we might be able to just nest it in a query like this and still get a response back. If that doesn't work, you might be able to switch the request method from a get to a post request, and then like URL encode this request body and include it in the URL parameters. That could show you better results. And so your protection is only as good as how easy it is to bypass, if that makes sense. But another example might be rate limiting. Let's say you have GraphQL in charge of your login stuff. So typically you have like a name for each query, but you can use something called aliasing, which allows you to basically just make temporary names, is the way I think of it, for each query you send. So even though it might be one HTTP request, you could send 100 different logins, and then the response would show you the results of all 100 of those logins. So it might not trigger conventional rate limiting or like brute force protections, but you would still be able to get the same results as an attacker. And just like any kind of request that a user could make, cross-site request forgery is no joke here. If, for example, the application is, I don't know, I mean, really, if it's not implementing those protections like a CSRF token, or making sure that you're using the proper, like, so for example, if you're using like a post request with JSON, that shouldn't work. But then again, if you see that, you might be able to just change it to a get and then URL encode the data in the URL parameters, and then you'll be able to get through just fine. So as long as you see something that's meant for one user and there's no protections there, it's worth trying to see if you can basically coax another user into performing an action on your behalf. But that being said, we can go ahead and jump into our lab. This is from the Cyber Apocalypse CTF from 2023. And then we'll come back here and talk about prevention. All right. Here we are in the challenge for this one. This is, I think this is called Passman is the name of this challenge. And we're greeted with a login screen first, and we can thankfully create an account. So let's just try it. We're just going to say Gabe. And I'm also going to start by capturing these. Let me make sure my intercept is on. I'm just going to send these to the repeater so we can look at them later. Looks like we registered just fine. And it looks like, cool, we're able to log in. Let me save that as well. And this website or web application, whatever you want to call it, I think is just meant to be like a password manager. So let's just add an entry here. And you can see that data gets put there. And this is a mutation, so it's changing some value. So I accidentally sent this to the intruder. Okay. Cool. So it looks like it's a password manager online. Kind of makes sense given the name. And we can, view and unview, probably depending on our cookie or our token or whatever. So let's go ahead and jump in. Obviously, we know that this is going to be a GraphQL thing, but if it wasn't obvious by the fact that it's in this video, it's right here in like all the post requests we're making, right? So let's look at what's this one? I think this is me logging in. So yeah, you can see it gives me like a session token, username and password. What I'm going to do is I'm just going to send another one of these to the repeater. And in Burp Suite, you can see this little GraphQL tab that shows us, oh wait, this is a mutation. Is this me making my account? String, password, login? No, okay, it's using this login user thing. But let's just go on like GraphQL Voyager, and we're going to copy the introspection query they want. And I'm just going to get rid of all the variables, and I'm just going to paste that up here, and hopefully this will work on the first try. Sweet. So I know it wasn't in the PowerPoint, but this is what the output of the introspection query looks like. You can see it's querying the schema. It gets all the query types, mutation types, subscriptions, It looks for basically just anything that you might find based on whatever. And we can see the response here, data, schema, query type. What's a good example? No subscriptions, it looks like. They've got mutation types called mutation. They've got queries. If we scroll down, we'll look at a couple of these manually, right? So let's see. There's address. So I think this is part of what? Name type. Deprecated. What is this? Owner. Okay, so this is your passphrases. So there's an object called phrases that contains your user ID, some other ID type. It's like a scalar. The owner. What else is there? There's the type, which is a string. The address, which I imagine is the, given the address is a string, it's probably this address we put here. Username is there, password is there, whatever this might be, and then the note. You get the idea. A handful of different things are present here. What we can do though, and what's really nice about like GraphQL Voyager and all these other visualization tools, is we can make this job way easier for ourselves. Actually, let me just, whoops, I don't know what I just did there. Let me just go back to the top, and I'm just gonna be smarter about this. And let me just paste all that in here. And you can see it's not as complicated. We can look at the phrases. Goodness, can I zoom out a little? Maybe? I guess not. Oh, that seemed to work. Okay. So we already kind of knew that this was one of the phrases they had. We can look at the mutations. We already saw login user a second ago, right? Which was not this one. Get phrase list was what pulled our like our password manager list. But this is a mutation, weirdly enough, and I think it's just because it has to generate a token or give us a token back. But login user is a mutation, right? And you can see register user is one, which I think is way back here. I don't think we can register the same user twice, though. Like if I do game 2. Duplicate entry. Oh, whoops. Let me try doing it like that. So yeah, there's another mutation, which is just changing some data in the database. Adding the phrase to our thing, but obviously the lucrative one here is update password. And I think we can even, maybe I'm going crazy. So yeah, you can see exactly what kind of data they're looking for in these. So like, let's look at a login user, for example. Oh, did I break it? There we go. So it looks for username, password, and then gives a response. If we look here at our login user, we gave a username and a password. So I'm just going to send this to the repeater again, and it gives us another token just fine. What we can do is, let's see. I'm going to change the mutation to update password because it takes the same inputs. So we're just going to say update password. It still takes username, password. It only replies, and I don't think this really shows here. Or yeah, message and token. How do I differentiate those? It's kind of hard to tell. Message and string. Message and token. It says it gives back both, but I don't know if we need the token back. I mean, we'll see what happens if we leave it in. And this is something, obviously we want somebody else's credentials, and you know, you're perfectly fine in guessing that admin might be a user on here. I'm pretty sure this machine, or this challenge, I should say, comes with a download where you can actually view the database of users, but you can't see their passwords. You can see other usernames. Again, not super useful here because we can just kind of guess. It's a pretty guessable username. It says authentication required for this. Let's see if I can just copy my session cookie to this request and see if that works. Okay, it says it changed the password successfully, so we'll try and log in as the admin user with pwned as the password. And it looks like that worked. So if I unhid this password here, that's where the flag would be. But of course, I highly recommend you go ahead and try and solve it yourself. It's a pretty straightforward challenge, as you just saw. And all we did was run the introspection query. We gathered some insight about the schema, more specifically the mutations that are here. And from that, we were able to basically just, you know, figure out how to change somebody else's password without any authentication needed. Well, it needed a cookie, but it didn't need the admin's cookie, which is obviously an issue, right? Depending on who you ask. But anyway, that's all we've got for this challenge. Let's go ahead and talk about prevention, and then we'll wrap up. All right, so as far as prevention goes, for unsafe introspection, all you're going to want to do is if you're using a private API, there's no need to have introspection enabled. Your developers will be able to just go look in the docs and see what the query looks like. They're not going to be able to do that on the fly. If you're hosting a public API, it's a little bit different, but basically, if it's a public API, you don't want to disable introspection so that other people in the public can go look at it. What you'll want to do then is just make sure that sensitive fields aren't really included or aren't accessible, and that suggestions, so like autocomplete or verbose error messages in GraphQL, are disabled when people are querying the API. If you want to prevent brute forcing, you can limit the query depth, so how many queries can be nested inside of one query, or just make it so that aliasing doesn't work. Another thing you could do is configure, strict limitations on like the maximum number of bytes a query could contain, or some kind of like cost analysis tools that determine how much computing power the request costs and denying it if it's too much. And then if you want to prevent cross-site request forgery, just make sure that you're only accepting application JSON as the content type over post, and make sure you're validating that content type. And then use typical CSRF protections like a nice secure CSRF token. So aside from that, that's all we've got for today. I'll catch you in the next one. Later.